I'm going to go back to bell work. All right, so again, symmetry means if we could draw a vertical line through the image, fold the image right through that line, that the right side would land right on top of the left side. So, for example, I'll draw more. Oh, hold on. Oh, so if I folded, whoops, doesn't really work great. If I folded that image on the orange line, that red line would fall right on top of that green one. They would match up exactly. And then we would have Christmas. So that is symmetry. We could do the same thing with the image on the right. If we folded it on the dotted red line, the right, okay, so keep in mind the X and the Y axis are not what we're talking about. Not folding it on one of the X or Y axis. Because in some questions I may ask you, where would the line of symmetry be? And you would have to be able to say, well, it would be at X is -1. That's where that red line is. Here it is at 0. You could say, well, it would be at X equals 0, or the Y axis is the line of symmetry, something like that. You do need to know where to fold it, in addition to just being able to say, yes, it is symmetrical. But that's it. That's the concept of symmetry. Go ahead, look at the, I'll have to get rid of that stuff because it doesn't scroll. So answer these two questions. There's one. I think there's another one below. Yeah, and then there's one. So answer the two, one example and then one check. I guess it's called, I think, below. Or I don't know what it's called. Just answer those two. I fix this. I'll give you a minute, shouldn't take long. If you're not sure exactly what the boxes are that are the blank boxes, just answer, is it symmetrical, yes or no? You can tell me where the line of symmetry would be if you think it is symmetrical. You do need to know how to explain why is it symmetrical. Like basically you just have to say what the definition of symmetry. You could draw a line down the middle of the figure and hold left side of the top. Pretty much always. I'll give you another 30 seconds. Oh my goodness, great. This is the easiest thing we do. I can't understand it. You know, anymore, I sat there and watched this song. Literally was thinking they're talking right there in the middle. Watching you talk while I was. You guys not know you're talking or aware that you're lying? Can't figure it out. Never figure it out. Because I will sit here and I'll watch a kid do something. Just watch them. They don't know I'm watching them. I'll sit and watch either they're talking or they're on their phone or something, and I'll call them out on it a couple minutes later. I wasn't doing that. I just sat here and watched you do it for 2 minutes. And kids will be like, I wasn't doing that. Like, I just don't understand if kids don't, like, are you not aware you're doing stuff in your head? And so you truly think you're telling the truth? Or you just, is it just that condition you just lie on something? Figure it out. But yeah, and that's what I'm saying. Like, I truly think what you do is you're on, there's a thing called autopilot. Like your brain will literally shut down. There's some things you can do. Like, I'll give you an example. If you drive, not yet, if you drive the same route over and over and over again, that'll go into autopilot. So you might get home and go, wow, I don't remember like passing that stop sign. Like I just totally remember passing that stop sign. I know it did because I drove home. Your brain just shuts some things out that it's used to doing. Simple, tiny things. That's why you lose like your keys sometimes. You forget where you put stuff. You're so used to putting stuff down, you don't think. In fact, look it up. All right. So is this, Kaylee, is this symmetrical? Why? So if where would I draw a line that would make me able to fold it and the left side would fall on top of the right side? So you think down the y-axis. So if I fold this, is this arrow going to land way up there? Yeah. Because it's symmetrical. And that's a no. There. That's all you got to think. And again, the line can be anywhere. I could draw a line over here, depending on what the image looked like. Oh, make this note. This was confusing when we get to practice. The arrows go on forever. So if the image doesn't look symmetrical in the picture, but it's got arrows continuing to go, and I'll draw one in a second. Actually, I'll draw one on this. So let's say we picked red. And I'm not going to probably draw a perfect version of this, but that's fine. There. That doesn't look symmetrical the way it's drawn, right? You'd say, well, if I fold this, this arrow is going to be way over here. But it is symmetrical. Because remember, this arrow goes forever. If you see arrows on the end, they go on forever. So this arrow would be down here if I folded it, assuming I drew it correctly. If I folded it right there, that arrow would fall on the other. So don't just go based on what is in the picture. You've got to think about what that full image would really look like. And in this case, this full image, this would keep coming down like that. They'd actually both go on forever. You see an arrow, they go on forever and ever. They never stop. So it is a symmetrical image. If I folded it right through this middle bottom, called a minimum, if I folded it through that, and if I put that right side on the left side, it would land right on top of it. So that's one thing that kids didn't understand yesterday when they did the practice. But a straight line, I'll just tell you right now, any diagonal straight line will never be symmetrical. You will never be able to draw a straight line. I don't care how you shape it. The only straight line you could say would be as if it was exactly flat. Because then if I fold it, the right side would land on the left. Any other diagonal straight line, I don't think you'd ever get a vertical line. But any other diagonal line, you can't do it. It's impossible. There will always be a bottom that will be lower than the other side. All right, so let's see if we can fill in the actual blanks. What do you think the first blank is? Sometimes it's hard to come up with these. Now, if you do the online book, they actually have drop downs. So if you ever did, like if I ever assigned something, it's really not that hard at all because it's pretty easy to figure out from the drop downs. We may do a quiz online one time. I do the computer lab. That would be my guess. There's no way to do it. There's no line you can draw through that blue line. And remember the X and the Y axis, all the grid lines, those are imaginary. They're not actually lines. So when I say through the line, that's the blue line, the f of x line, through the function. There's no line, so the function, it's either does or does not. So which one is it? It does or it does not display? Does not, right? There's no symmetry there. Good. Does not. Boom. And we're done. What about the bottom one? Same concept. Is there a spot where I can draw a vertical line? And then if I folded it on that vertical line, the right side would land on top of the left side. What do you think? Raise your, okay, here's how we'll do it. Raise your right hand if you think yes. Oh my goodness, you did not just do what I thought you did. You did, no, that was you. You know what I'm talking about. So, share it if you want. This one. So, your right hand if you think yes, your left hand if you think no. Better see every hand up. You got a 50-50 chance. Right hand is yes, that is symmetrical. Left hand is no. Oh, this is an easy section of the quiz. Actually, if you get this section of the quiz right, and then there's one other problem you have to get right, and you pass it. Even if you get the rest of the stuff wrong. So I'm making sure we know how to do symmetry. Aiden, wake up. I need you to look at this, bud. Even if you're not taking notes, you need to know if this is symmetrical or not. Can I draw a line somewhere down? It would technically be the middle of it. Can I draw a line vertically that would allow me to fold the right side on the left side? 5 right hands. Oh, did you just not confuse your right and your left? You should do that the time I did. So, it is symmetrical. Where would I draw the line? That would be like the next level of understanding. Yeah, through the 1.5. So if I drew a line, and my pen is probably not great. So if I drew a line right there, well, that's a pretty good line, considering my board. If I drew a line right there, and if I folded it. So here's a quick tip. The pieces of the line that are easy to check, look for points where it's curved, or it could even be a point, and then look at the end points. Those are what you're trying to match up with. if you can match both of those up, so again, this curve would fall on that curve. This endpoint would fall on that endpoint. You can match that stuff up. Like, don't worry about all of this and all of this so much. If the curve parts match up and the endpoints match up, you're probably. And with that straight line, if you just looked at the endpoint, when you folded that over, that would have been way below the other endpoint. So make that quick note if you want. Match up the curved parts, or again, it could be, doesn't have to be curved. It could be a straight line and still be symmetrical, like an M. Oh, what letter? Oh, that'd be a good one. What letters are symmetrical? Give me a letter that's symmetrical. M is, because I just drew it right. So M would be if I drew it right down the middle. Give me another one. N is not, so N would not be. N you might think would be, but again, if I drew a line here, if I fold it over, that point is not going to land on that point. So N is not. T would, like I'd literally draw it right down the T. It's almost the definition. If I drew my vertical line right down where the vertical line is, U. So if U is, W is. I, that's just straight line. P would be another one. X would be one, right? X would be, well, what? 8 would be a number, if you want to think numbers, 8, well, 0, 1. Yeah, so just those, not a lot of numbers, unless you get in double digits. So that's a good question. I like that one. What letters? Name a letter and a number, and they're symmetrical. I would, except I've already made up the quiz. And I am too lazy to go back and change it, especially since I've already made it. I'm ready to go. So since I've already made up the quiz, I'd pay attention to anything I really emphasize today, since I know what's on the quiz. All right, so let's go to the next. I didn't have it made up yesterday when I did the lesson for them, so they didn't get as much information as you're getting today. Just consider yourself lucky. I didn't really spend any time on that. I'm not going to worry about that. I'll let them do that with you next year. Okay, you do have to know this. Again, this is super easy. This is the other part that if you get it right, you pass the quiz. If you get symmetry right, and if you get this right, you pass the quiz. So there are these things, I guess they call them extrema. I've actually never even heard of that word personally. It's a different book. They do some different things. But there are, we do teach minimums and maximums. We didn't actually teach it in 1A last year, but in algebra they will, since it's in our lesson and it's pretty easy. A minimum or maximum is like a point where the line changes direction, sort of. Like it's going down, it's decreasing right here. Oh, then it starts increasing. And then it starts decreasing. So those are minimums and maximums. I guess technically relative minimum, relative maximum. It does go higher than this maximum. It does go higher on the end and lower on the other end. So it's really just a point where, yeah, like I said, you change direction. You're changing, and it doesn't have to be curved again. So I think it normally will be. So that could be minimums and maximums if it's not curved. How would you describe the minimum? Like if I was going to ask you, describe the minimum or which point is the minimum, what would you say? How would you find the minimum? Well, how though? What are you looking for minimum? Yes, it is. It is. No, you're right. It is. Oh, you're right. No. You're right though. Like, it is.
It's so funny. He's like, how would you describe that? She goes,
so what would we look for if I ask you to find a minimum? What are you looking for? See, I just told you one thing to look for. So it's like the bottom curve part, right? So it changes direction. So that's one thing you would look for, although you really wouldn't think of it that way, probably. You would just think of it more as a curved part. You could think of it as like a U or an upside down U for the maximum, or a V or an upside down V. So that's an upside down V, that's a V. But those are the minimum maximums. I'm not doing a whole lot more lesson than what I just told you. If you are struggling to understand that, so again, it's nothing to do with the endpoints of the line. We'll get to that. That's the last piece of the lesson. So within sort of the middle of the data, minimum, maximum. Don't think that's super complex either. If you're not getting it, that's the question. Yeah, there was one part of this that I just did not know how to teach. Well, plus the other thing the other day, see things different ways. So if you're struggling, I guarantee you're not the only one that doesn't get it. I need somebody to tell me to figure out how to explain it. Go ahead. Actually, I don't even think they give you this. That was so easy. They don't even give you an example to do. Yeah, they don't even give you an example. There are example problems in the practice, but so you can see if you're getting it. One, two. All right, so we're halfway through, although these next two are more difficult than those first two. All right, so this one was a little tricky. I'm going to change it a little bit. So when it comes to a curved part of the line, so this is a curved part of the line, we are changing directions. That's sort of why I use that concept. Anytime you have a minimum or a maximum, you're changing directions. The line is going to either go from increasing to decreasing or the other way around, from decreasing to increasing. You always read it left to right when you're trying to figure out, is it increasing or decreasing? Now, here's the tricky part. This is whether or not the function, the entire function is increasing or decreasing, or I should say, where is it increasing and decreasing? We're going to also learn what's happening with the endpoints. Are they increasing and decreasing? It's two different things. You got to figure out how to keep that straight. So if it asks you is the function, so I would make this note maybe. If it's asking if the function is increasing or decreasing, then you're reading it left to right. So write that. So if it's asking about the function, you're reading it just like you would a book. You're going from left to right. Reading the graph left to right. So I'm going to start on the left, and I'm going to continue to go to the right and see where the graph is going down versus where it's going up. When we get to the endpoints, we actually we'll go left as well as going right to read the endpoints. And there's always only two endpoints. We'll just go left and just right. So now, here's the next thing you got to understand. Some of you will get it immediately. Some of you, it'll be, at least based on yesterday, it was tricky for quite a few people. If I'm going, so again, I start at the left end. So here's the left end right here. That's the left side. As I go to the right, what's happening with that line? It's, well, what? Well, the blue line, oh, can I zoom in? Yeah. I'll get rid of that green stuff. So I'm starting here. I'm going that way. Again, I go from left to right. What's the line doing? That blue line from where I circled, what's it doing? It's going down, right? The line, if I'm following, so think about if you were, are you sliding down the line or are you climbing up the line? If you were putting yourself right here, would you be sliding down or would you be walking up? Sliding down, right? You would slide down that line and then you get down here and you just stop, right? You're not going to continue to slide up. So you'd slide down here. I'll show you. Again, amazing artist. There you are, right there. That's me. So I know, big line. So I would get on that line. I would start on that line on the far left, and I would slide down that line. I can't really draw me sliding. I would slide down. But what's going to happen down there when I'm sliding down? I'm going to stop, right? I'm not going to slide all the way up. I'm going to stop. I'm going to stop down here. I would be sitting down at this point. I'd be sitting down. I slid down. That's decreasing. You're sliding down the line. That was decreasing. And you guys did such a better lesson. No sliding. Nothing. Now I got to stand up. Stand up in red. I got to stand up. I want to get to the end of the line. That's my goal. I want to get back up there. What do I have to do? Climb up. I am increasing. I'm going up, right? If you're walking up, it's increasing. Sliding down, decreasing. Walking up, increasing. That's what you're looking for in the graph. That's the first thing. Then there's one more piece you got to figure out. So decreasing. Green is decreasing. All right, so that's what you got to figure out first. Where are you sliding down? Where are you walking up? Here's the last piece. And the number part of this is always the same. Because if you'll notice, I'm sliding down to this point. I'm walking up from that point. So the number will always be the same in this last part. You write where the graph is increasing or decreasing. You write it based on what the values of x are. So again, remember that's my x-axis. That's the x-axis. So I've got to say, okay, what are the values of x that would match up with the green part, the sliding part? Give me a value of x where I would be sliding. What matches up with that green side? No. Don't ruin it. Only one. So what's that? What values of x would match up with the green, not the green x-axis. Let me get rid of that. -5 would work, right? A negative would be, so where is that? 1, 2, 3, 4, 5. A -5 would work, right? That'll be, now, because remember, this goes on forever to the left, so it's going to continue to go forever. Even though -5 doesn't look like it's under there right now, that line's going to go up and left forever. It might take a while to get out to -5, but it'll eventually get there. It's always going to be going left the higher it gets. So -5 would be under it. What else would be under it? -3 would, right? -3 is definitely going to be under it. It's almost under it already. What else? Oh, and I shouldn't say under. I should say it matches up with it. Under it's probably a bad statement. -2 would work. It could be over it also. So I'll just tell you -1 works, right? That x value matches up with the green part. You're just looking for what is the x value for the point. All of these points here, every point on that line, I'll just tell you the answer. Every point on that line is going to have a negative x. Because my 0 point, or my bottom out point, is x equals 0. Everything left of that, I know, this is kind of like the positive negative thing. Like when is the graph positive, when is it negative? So again, you're always going to use, I'm just going to tell you the short version. Your number is always going to be where the curved part, or if it's a pointy part, where it bottoms out, where you change direction, where you stop going up and you start going down, or you stop going down and you start going up. It's the minimum or the maximum, always, because that's where you're changing directions. I stopped going down at that point and started going up. So here's how you write it. X and 0 for this one. It's not always 0, so I don't think it's always 0. Some kids yesterday thought it's always 0. It's always going to be x is either greater than or less than, and then again, the number will always be the bottom or the top of it. And there might be two. You sometimes might have a minimum and a maximum, which means there's going to be two things you'll have to write. So would x, if I wanted it to be decreasing, I'm talking about anywhere where that line is decreasing. Would x have to be greater than 0 or less than 0? Look at the numbers we wrote up. Yeah, have to be, they're all negative, right? It's all negative numbers. Any negative number that I use for x, and that's the part of the line where it's going down. So it would have to be x is less than 0. That's where the graph is decreasing. The short version is the opposite's going to be true for increasing, because this is where I change directions. If I'm not increasing, or if I'm not decreasing, then I must be increasing. But let's look at it again. Anytime I'm increasing, anytime this line is going up or I'm walking up, it's going to be associated with an x value that's positive. All those x values, every x value to the right. I'm going to be walking up that line. Now, again, some of these are not under the line. They're not matching up yet, but that line's going to go on forever. Never stops. Lines don't stop. So anytime I'm walking up that line, I'm going to have a positive x. So it would be the opposite for increase. So that's what it means when it says, where is the graph increasing? Where is it decreasing? You have to figure out where are you sliding down? Where are you walking up? The number part's always just going to be either the minimum or maximum. So if this would have been flipped upside down and it would have been an upside down U, I would have taken the number at the top and then I would have been walking up first, then sliding down. So the greater than and less than would have been switched for that one. So it's not always that you're decreasing when you're less than. It's not always that you're increasing when you're greater than. So again, you're going to practice some of these. So if you're not seeing it, that's why I say you got to practice today. This is your only lesson. Might review it before the quiz on Friday. But if you practice them, you'll be fine. The quiz is going to be the same exact thing that you see when you practice it. All right, so that's the third thing. I told you that was going to be a little difficult, more difficult than the other stuff. Anybody have a question that they're? No, half of you have questions. Brave enough to ask. All right, you can practice it, and I'll be walking around. You can work together too. So if you couldn't figure it out, and somebody next to you understands it, they can help you if you're scared. Well, we're not done yet. We got one more. All right, so here's the last thing. So look at page 107. So this is what I said might get a little confusing along with the increasing or decreasing. If it's asking you if the graph is increasing or if the function is increasing or decreasing, you're only reading that left or right. If it's asking you what the end points are doing, or I guess they call it end behavior, I would call it what are the end points doing? What is the end point behavior maybe? This one here, you have to read both left and right. I'll show you what that means. Because there are two endpoints, right? This is an endpoint is just where the arrows are. It's always going to be two. Doesn't matter what shape the line is in. I guess if it wasn't a line, you might not have two, but you would only have lines. If it's a dead straight line, you still have two arrows at the end. If it's a curved line like this, you have two arrows. If it's a curved line like that, you would have two arrows. If it's a curved line like this, you would have two arrows. So there's always going to be two arrows that you're checking. Maybe a note you want to write, make sure you check both arrows, both endpoints. Get rid of, is anybody writing stuff that I wrote? So let me go from the computer. My board's still messing up. So here's how you check them. To check the left, you can write exactly what I say. This will work. To check the left arrow, you want to go from the right to the left. So if I'm checking this guy, I'm going that way. I'm reading it from right to left. I'll explain what you're actually going to do. The reason I'm doing that is because the way you're going to write the answer, they kind of write it right here. You're going to say as x decreases. What does that mean? X decreases. As x decreases. Means we're going left, right? If I'm going left, I'm on a number line, think of a number line, right? So as I'm going left, the numbers are decreasing, right? That's what a number line is. If you go right, numbers are increasing. If you go left, they're decreasing. That's all this means. It just means you're going that way. So that's why you're going left, is because you want to write as x decreases. So this is always going to be the starting statement for the left arrow, because you're checking that as the x values decrease. So as the x values are getting smaller, as I'm going left, what's happening to that arrow that I circled? Which direction is it going? Not really, I mean, it's going left a little bit, but what's happening with the Y? We're checking to see, are we going up or down on the Y axis? Going up, right? I mean, the arrow is literally pointing up. So you'd never write left. I'm glad you said that. It's either increasing or decreasing. You just need to figure out, am I going up? Am I going that way or that way? That's what you're figuring out on the y-axis. Well, as I go left this way, on this axis, I'm going up. So as in this case, as x decreases, y increases. I'm going up. For the left arrow, that's why it's decreasing. The left arrow is always as x decreases, by the way. You can, if you want to just make that note and memorize it, that's fine too. Always, 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 for the left arrow, you're going to be decreasing with your. At least I can't think of a situation, even a weird, tricky, where they're going to intentionally try to trip you up. I don't think there's any time where that's ever going to be incorrect. You're doing the left arrow, you have to be checking as x goes left, as x decreases. So now, if we're going to do the right arrow, so we'll do that in red, it's just kind of the opposite. Now, the final part, this is not always the opposite, but your beginning statement is always opposite. You want to check the right arrow as x increases, because you're now going to check it by going to the right on the x-axis, to the right on the number line, which means the x values are getting bigger, go to the right. So you want to write as x increases whenever you check the right arrow, but you're still matching the y part up with the y-axis. So what is that arrow doing relative to the y-axis? Is it going up or is it going down? Going down, right? I mean, this one's pretty easy to see because it's literally almost going straight down, which means the y values are going to get lower and lower and lower. So the y values will be getting lower as the x values increase, as we go to the right. As I go to the right, these numbers are getting lower. So that would be y decreases. Again, they're not always the opposite. Don't think that one's always going to, like for the y, I'm talking about for the y values. These are always opposite. This is always as x decreases for the left, always as x increases for the right. But the y values do not have to be out. They could be the same. Think about it. If we have that graph, the y values, I don't care which arrow I check, the y values are always going to be decreasing. As x increases, y decreases. As x increases, y also decreases. This one would be the opposite. And again, they don't have to be curved. It could be like that. The word is, it's weird. When I write over here, my word's way off. The endpoints on these, the endpoints on those are always going up. Doesn't matter if I'm increasing. I thought that was my student, so she knew before. This is March. Let me finish this real quick. So, as x increases for these, or as x increases or decreases, doesn't matter. If I'm going left, the arrow is going up. I'm going right, the arrow is going up. So your y is always increasing. Doesn't matter if x is increasing or decreasing. So here are the problems, and that's the last thing you need to know for Friday. These are the problems. If you can do these, there's not a ton of them, so don't either let somebody else pretty much do it for you, or don't just can't come up with them. Don't just sit there and cheat and concepts. Not gonna do any good. There aren't that many of them. So if you need to truly focus on the ones that you do, because there's only 4 practice ones for each section. If you're just sitting there writing stuff down real fast and you don't really understand it, when you get my quiz, you're gonna do poorly, and it's not a difficult quiz. It should be an easy grade if you practice today. I'll walk around and help. I'm gonna do attendance first real quick in my focus, but I'll walk around and help after that. I don't care if you work together, again, keep in mind, you have to do your own quiz. Your marked absent. You just. Oh, yeah, I don't mind. So here's the deal. I'm gonna let you use phones while you do this. I'll just tell you, I didn't tell you yesterday because it's a test to see if you can work and use phones. I get you, because I don't think any of this is difficult. Even if you do, you better be asking me questions. So if I get to you, like, I don't, and it's been like 10 or 15 minutes gone by, and you've done nothing, you say, oh, I don't understand it, phones will not be used in the class. Clearly, you're just sitting on your phone. Do your work while you have your phone out. I'm fine with it. Aiden, you need pages, bud. Hey, come on. Good, you got to practice. All I'm doing. Yeah. Oh, yeah, if you didn't see, again, your pages are these pages and problems right here. 1 through 4 on 109, 7 through 14 on 110, 17 through 20 and 111. So, go ahead and go. Hope you're working back there. Hey, just one minute. Yeah. Did you see anybody else from this, like Daniel or anybody? I know his bus is late all the time also. So you kind of missed the whole, let me stop the recording.